Here is the second example in this series. The bowling ball now is being pushed by a broom across the floor. So there's the picture, and the arrow with velocity implies that it's moving to the right, speeding up. System schema is what it was before with the bowling ball at rest on the floor, but there's something different. We have to add something. We now have the broom. So let's add the broom to the system schema. And the broom is interacting with the bowling ball. It's a push. I'm going to call that a normal force. And we're not quite done, because now that the ball is moving, we have to consider a couple other forces. Because it's moving across the floor, there's rolling friction. So we would think, hey, the floor is also interacting, not just supporting the ball, but there could be some friction. Now we have to decide, is that significant or not? With the bowling ball in the gym, we saw that the ball would roll on at a constant velocity for a while. So let's assume that that is not there. Also, it's moving through the air. So if we consider the interaction of the ball in the air, we talked about the buoyant force in the previous example and said, well, that's always very small force with something submerged in air, so we will not count that. But it's moving through air, so there may be a drag force to consider. If it was going fast, that would be significant. If it's just rolling rather slowly, it won't be. So let's not include it. Therefore, there's no significant interaction with air. So now we're ready to make the force diagram. We've considered all the different interactions. So as before, we have the gravitational force down. It's the same as I listed before. It's on the bowling ball, and it interacts with the whole mass of the Earth. There's the supporting force of the floor, which is a normal force on the bowling ball by the floor. So we've got that force and that force taken care of, and that means the broom force pushing it to the right. So there is the normal force on the bowling ball. I'm running out of space, so I'll just put B for broom. And now we see, we know that these forces are balanced because the ball's not accelerating up or down, but there is one force extra which is unbalanced, and that will cause the ball to accelerate to the right.